Good evening. Welcome to Unacademy, the largest online e-learning platform, and welcome to Unacademy semester exams, circuit theory crash course, lecture number 5. Today we are dealing with AC circuits, RMS and average values. I request you all to please like and share this to as many as possible so that the students get benefited for the semester exams. Before this, let me tell you I am Vai Shravan Kumar, having 7 plus years of experience and mentored more than 5k students for GATE and engineering services and cracked GATE. Let me also tell you the Unacademy Learning App installation procedure in Play Store. Type Unacademy Learning App, you'll get this and click on this install. As a step 3, you can click on GATE and engineering services and click on plus, and if you click on this get subscription in step 5, you have plus and iconic subscriptions. You'll get a dedicated mentor for your preparation in this iconic, and you can also use my code as YSK10 to get a maximum discount. And if you click on this proceed to pay, you'll have payment options using debit card, credit card, EMIs, UPIs, wallets, and net banking. Using any of these platforms, you can get subscription to Unacademy. Rakesh, good evening. Soumya, good evening. Raju, good evening. Welcome you all to Circuit Theory Crash Course. So today's topics are RMS value and average value. I'll also tell you what is an alternating quantity or what is an AC quantity. And we will also see some terms like what is firm factor and crest or peak factor along with this. We'll also see the differences between DC and AC quantities. So let me first start. What is an alternating quantity? What is an alternating quantity? So some of the students were asking me about the clarity of the screen. I request you to just click on your screen and see there are 3 dots on the right top corner. If you click that, there will be a pop-up, and in that you need to click on the quality and set it to 480p so that the picture or the screen is more clear for you. SR, hi sir, good evening. Good evening, SR Srinivas. So what is an alternating quantity? A quantity, no, a quantity that changes periodically in both magnitude and direction is called as an alternating quantity. Augustus, good evening. So let us take a graph like this. Now if you consider a sinusoidal waveform which is varying alternatively, this is 2 pi, this is pi. Either this can be voltage or current, and this can be T or theta. Alright, so this is a positive half cycle, this is a negative half cycle. So it has 2 half cycles. It has 2 half cycles. One is positive, other one is negative. And combinedly, these two are called as one cycle. We'll also look at these definitions one by one. Now, this value is called as V maximum, and this is called as minus V maximum. So, this is Vm is a peak or maximum value. peak or a maximum value is Vm, and omega is angular frequency in radian per second, and omega t, small t or capital T, is called as argument in radians. So now let us see what are the differences between AC and a DC quantity. Let us see the differences between AC quantity and a DC quantity. We can just differentiate them because we have seen DC quantities in the previous lectures. Now we'll see what are the major differences between them. The first one would be it has a constant magnitude. It has a constant magnitude, whereas an AC quantity is one whose magnitude and direction changes. This is the first point. Now coming to second one, this is the first difference. Now coming to the second difference, the frequency in a DC is 0, whereas the frequency in an AC is not equal to 0. This is the second difference. Now coming to the third one, lowering or rising voltages is not easy in case of a DC, whereas it is bit easier, is very easy. Lowering or raising is very easy in case of a AC. Now let us look at the other difference. It is the DC machines are expensive. DC machines are expensive. DC machines are expensive, whereas AC machines are cheaper. And coming to the next one, DC machines require frequent maintenance. Require frequent maintenance, whereas AC machines require less maintenance. So these are some of the differences between AC and DC quantities. These are some of the differences between DC and AC quantities. Now let us look at the different definitions. Now if you look at the different definitions, let us first consider what is an instantaneous value. Instantaneous value. What is an instantaneous value? You must have read about this, and let me also tell you. Shivakumar, good evening Shivakumar. Welcome to Circuit Theory Crash Course. It is the value of alternating quantity at a particular instant is called as an instantaneous value. Now let us take, if you take one graph like this, and if you draw a sinusoidal waveform at any instant, if you take at this instant, now the value at this instant is, let us say, E1. So this E1 is called as the instantaneous value at any instant if you take. So it is an instantaneous value. Now let us take what is the second definition as. Second definition as what is a waveform. What is a waveform is now What is a waveform? Waveform is a graph that you already know. The graph of it is the graph of instantaneous values of an alternating quantity is called a waveform. Is called as a waveform. The waveform that you draw with the instantaneous values is called as a waveform. Now let us look at the third definition. What is a cycle? What is a cycle? You already know that. What is a cycle? What is a cycle? What is a cycle? A cycle is each repetition of positive and negative instantaneous values of an alternating quantity of an alternating quantity is called a cycle, or the positive and negative constitute a cycle. Now let us take the next definition as what is time period. What is a time period? Yeah, one positive and one negative waveform is called as cycle. Very good. Good evening, Ishwar. Welcome to Circuit Theory Crash Course. What is a time period? The time taken for the time taken by an alternating quantity to complete one cycle is called time period. I'll just show you all these things. So these are some of the definitions. You can also have much more definitions like what is frequency? Frequency is the number of cycles per second. It is denoted by F and units are hertz. What is time period? Denoted by T, units are seconds. Alright. So these are some of the definitions. To complete one cycle is called as time period. Very good. To complete one cycle is called as time period. That's very good. So we have seen what is the difference between AC and DC, and also we have seen what is an alternating quantity and differences between DC and AC. Also we have seen what are instantaneous values, what is a waveform, what is a cycle, and what is time period, and what is frequency. Now let us look at average and RMS values. Now first I'll tell you these two things parallelly. Now let us take what is an RMS value. The other one is average value. Let us look at these two, and first I'll tell you these are based on what, then I'll tell you what is average and RMS value. Now RMS value is based on heating effect. RMS value is based on heating effect, that you have to understand. RMS value is based on heating effect and average value is based on charge transfer. It is based on charge transfer. So now if you consider, let us consider a DC circuit and an AC circuit. Now, if I say the heat produced in this and the heat produced in this, if WDC is the heat in DC and WAC is the heat in DC, so RMS value is the value, RMS value or voltage is that voltage, the voltage at which heat dissipation in AC circuit is equal to heat dissipation in DC circuit. So these two are equal. The voltage at which these two values are equal. Abhishek, hello sir, good evening. Thank you Abhishek. Good evening Abhishek. So the voltage at which heat dissipation in AC circuit is equal to heat dissipation in DC circuit, provided they are operated at same time. They have R value as the same and this operated at same time. This is the condition. If we operate both with same R values and with same time, the value at which the heat produced I square RT, if I is the current and this I square RT, heating in this and heating in this, when these two are equal, that value is called as the RMS value. RMS is root mean square value. Root mean square value. Now if you take an average value, if you have a DC circuit and an AC circuit, this is a DC circuit, this is an AC circuit, let us take this as resistance and let us take the current as I and this as I. Now what is average value is, it is that value of voltage, average value is voltage at which the voltage at which charge transfer in AC circuit is equal to charge transfer in DC circuit. The charge transfer in AC circuit is equal to the charge transfer in DC circuit. This is Q is equal to I into T. This is Q is equal to I into T. That is QAC is equal to, if QDC at a particular voltage, that voltage is called as the voltage value that you get is called as average value. This is RMS value. Simply RMS value is based on heat transfer or heat dissipation and average value is based on the charge transfer. So the voltage at which heat dissipation in AC is equal to the heat dissipation in DC is called as an RMS value, and the voltage at which the charge transfer in AC is equal to the charge transfer in DC, it is called as a average value. Hope you are clear with this average and RMS values. Average value and RMS value. right? So we have seen, I'll just tell you what we have seen. We have seen what is an alternating quantity and what is a maximum V, maximum value, angular frequency, argument, and what is the difference between DC and AC quantity, and also what are instantaneous values, waveform, cycle, time period, and frequency. And we have seen what is the difference between RMS value and average value. Average value is that voltage at which the charge transfer in AC circuit. This is an AC circuit. This is a DC circuit. Similarly, this is an AC circuit. This is a DC circuit. Now, if the voltage at which heat dissipation in AC circuit is equal to the heat dissipation in DC circuit, that value is called as the RMS value. And if the voltage at which the charge transfer in AC circuit is equal to the charge transfer in DC circuit, that value is called as the average value. Now let us write expressions for average and RMS values. Let us take RMS value and average value. Mathematically, you can write, if it is a voltage or a current, voltage is equal to root mean is 1 by t integral 0 to t p of t dt. This is the RMS value. Square, you need to square it. Similarly, average value is V average is equal to 1 by t integral 0 to t p of t dt. Integral 0 to t v of t dt. So this is the expression for RMS value, and this is the average value calculation expression. So this is RMS value is equal to 1 by under root of 1 by t integral 0 to t. What is t here? T is the time period. T is the time period. Here also t is time period of the given waveform. Now let me tell you what is a symmetrical and an asymmetrical waveform and how do you find RMS and average values. Let us consider symmetrical and asymmetrical or unsymmetrical waveform. Now if you have a waveform, let us consider two waveforms and you will clearly understand what is a symmetrical and an asymmetrical waveform. Now if you consider a waveform like this, which has both positive and negative half cycles same, let's say this is V and this is theta, and this is V and this is theta, and let us take a waveform like this. Now let us say these two are the waveforms. Now you can say clearly that this is a symmetrical waveform which has both same positive and negative half cycles. But if you see the symmetrical, this is an unsymmetrical waveform in which the positive and negative half cycles are dissimilar as unsymmetrical waveform. This is a symmetrical waveform. What if this is a symmetrical and asymmetrical waveform? What happens? For a symmetrical waveforms, this is very important. For a symmetrical waveforms, V average value is equal to 0 if you consider full cycle, because it is a symmetrical waveform. Being a symmetrical waveform, average value is 0. That is the reason we will calculate V average for half cycle in case of a symmetrical waveform. In case of symmetrical waveform, we need to calculate average value only for half wave. This is pi, this is 2 pi. So in case of an asymmetrical waveform, in case of an asymmetrical or unsymmetrical waveform, V average is not equal to 0 for full cycle. So V average is calculated for full cycle in case of an asymmetrical waveform. This is one important point that you need to understand. So these are the expressions for average and RMS values. Average value, RMS value, and these are symmetrical and asymmetrical or unsymmetrical waveform. For an unsymmetrical waveform, V average value is not equal to 0, and for a symmetrical waveform, V average is 0 for a full cycle. So V average is always calculated for half cycle. V average is always calculated for half cycle. Hope this point is clear. Right? Here omega t is equal to 2 pi. So T is equal to 2 pi by omega. What is the frequency F is equal to? 1 by frequency F is equal to 1 by time period, that is omega by 2 pi. That is why you will write omega is equal to 2 pi F. Okay, this point is clear, I think. Now let me conclude what we have done in this, then we will move on to some of the important questions, and I'll also discuss what is form factor and peak factor. Now what I have discussed is what is an AC quantity. First I have discussed what is an AC quantity, then what are the differences between AC and DC quantity. See, we have discussed what is alternating quantity, peak value, omega. Then what is the difference between DC and AC? Then the definitions, basic definitions, then RMS and average values. Then we have discussed basic definitions of a waveform. Then I have told you what is RMS and average value definition. Then we have discussed what is symmetrical and unsymmetrical waveform. Also we have written expressions for Vrms as Vrms is equal to root over 1 by t integral 0 to t V of t square dt, where t is the time period and V average value is equal to 1 by t integral 0 to t V of t dt. Now let me tell you what is form factor and peak factor. Peak or crest factor. What is form factor and what is crest factor? This is denoted by Kf and this by Kp or Kc. What does this is? It is the ratio of RMS value to average value. and it is the ratio of maximum value to RMS value. This is one of the important question that generally being asked in your examinations. So this is KF is equal to VRMS by V average, and this is KP is equal to V maximum by VRMS. V maximum by VRMS is the VRMS by V average is the form factor, and Vm by VRMS is the, that is what is KF? It is RMS value to average value. What is KP is equal to? It is maximum value to RMS value. So let us now try to find average and RMS values for a sinusoidal waveform. Let us consider one sinusoidal waveform here. Let us consider a sinusoidal waveform with the time period 2 pi. This has voltage, this has V maximum value, this has pi, and this has pi by 2, and this has theta. Now a sinusoidal is represented by V of t is equal to theta, or V is equal to Vm sine omega t. Vm sine omega t. Now if you want to find RMS value, if you want to find RMS value, that is VRMS is equal to root over 1 by t integral 0 to t V of t whole square d theta. Let us take it as V of theta and d theta. Now this we can write root over 1 by t is 1 by 2 pi in this case, integral 0 to 2 pi Vm sine theta. Omega t can also be written as Vm sine theta into d theta. Now if you try to solve this, root over 1 by 2 pi integral 0 to, this is a square, 0 to 2 pi Vm square sine square theta d theta. Now let us try to simplify this further. Let us try to simplify this further. Now if you write this, what you'll get? Root over, first we'll try to find what is, first I'll try to find what is integral 0 to 2 pi Vm square sine square theta d theta. Now what your Vm square is constant, 0 to 2 pi sine square theta d theta, but we know that cos 2 theta is equal to 1 minus 2 sine square theta. So you can write from this 2 sine square theta is equal to 1 minus cos theta, and sine square theta is equal to 1 minus 2 cos theta by 2. So if you substitute, I'm only solving this now. So let us try to do that. So integral 0 to 2 pi Vm square is a constant. Sine square theta d theta is equal to Vm square integral 0 to 2 pi sine square theta can be written as 1 minus cos 2 theta by 2 d theta. So you can write Vm square by 2 as constant, integral 0 to 2 pi 1 d theta minus integral 0 to 2 pi cos 2 theta d theta. Hope you are able to understand this. So this is Vm square by 2 integral theta. It is theta from 0 to 2 pi minus cos 2 theta is minus sine 2 theta by 2 integration from 0 to 2 pi. Right? Hope you are able to understand this. 1 minus cos 2 theta. So it is Vm square by 2 into sine 0 to 2 pi is a 0 value. So this is 2 pi you can write it as. So this can be written as so it is we will write this as Vm square by 2. So it is 2 pi minus 0 minus 0. If you still further write this, if we'll take this under root, so this value we have got it as Vm square by 2 into 2 pi. So if you substitute this, it is under root of 1 by 2 pi 1 by 2 pi. This integral value is Vm square by 2 into 2 pi. Vm square by 2 into 2 pi. So 2 pi will get cancelled. So root over Vm square by 2 is Vm by root 2. Therefore Vrms of sinusoidal waveform is equal to Vm by root 2. This is the RMS value of a sinusoidal waveform. Now if we look back, we have taken a sinusoidal waveform with a period of 2 pi. So Vrms is equal to 1 by t integral 0 to t v of theta whole square d theta. Right? So RMS value, finding RMS value is very easy. For a sinusoidal waveform, we have taken Vrms as 1 by t integral 0 to t v of theta square d theta. Or you can also write v of t and 1 by 2 pi integral 0 to 2 pi Vm sine theta square d theta. Now if you complete this integral, you will get this value and finally V RMS value is Vm sine omega t. Now let's try to find what is V average value. So let us try to find average value of sinusoidal waveform. As I told you, because it is a sinusoidal waveform and it is a symmetrical waveform, we need to consider only half cycle. Therefore, V average is equal to 1 by t integral 0 to t v of theta or v of theta d theta. We already know v of theta is Vm sine theta. So we can write V average is equal to 1 by t because for a sinusoidal waveform, as you know, this is a sinusoidal waveform. I'm going to draw that. So this is sinusoidal waveform and it has a positive and a negative from 0 to 2 pi. This is theta and this is v of theta and this is pi. So you only need to consider 0 to pi Vm sine theta d theta. This is 1 by, so this is 1 by pi Vm you can take constant integral 0 to pi sine theta d theta. So you can write, I want at least one of you to tell me this answer of average value. So Vm by pi, what is integral sine theta? It is minus cos theta from 0 to pi. So that is V average value is equal to V average value is equal to Mulkala Koteshwar. Hi sir, good evening. Good evening Koteshwar. So V average is equal to Vm by pi. So if you substitute this, minus pi is minus of minus 1 minus cos 0 is minus of minus 1. You'll get V average value is equal to Vm by pi. So this is 2. Minus into minus plus 1, minus into minus plus 1. So you'll get 1 plus 1 as 2. Therefore, V average value is equal to 2 Vm by pi. You can also write this as 0.637 Vm. Therefore, V average value is equal to, yeah, Vm by 2. No, it's 2 Vm by pi. If it is 2 Vm by pi, V average value is equal to, previously it is Vm by root 2, and this is 2 Vm by pi. V average value is equal to 2 Vm by pi, or V average value is equal to 0.637 Vm. Divide 2 by pi, you'll get this value. You'll get this value. Srinivas, good evening. Good evening, Srinivas. Welcome to Circuit Theory Crash Course. Now with this information, let us try to find what is firm and peak factor. Vm by root 2. What can you write as Vm by root 2? What is 1 by root 2? What is 1 by root 2? It is 0.707 Vm. So we know two values for an sinusoidal. Vrms is equal to 0.707 Vm and V average is equal to 0.637 Vm. Now, can we find firm factor and peak factor from this? Yes. What is firm factor? Kf is equal to Vrms by V average value. What is Vrms? 0.707 Vm by what is average value? 0.637 Vm. Can someone tell me what is this ratio? 0.707. Now, I'll write Kp, then what is peak factor? Peak factor or crest factor? It is maximum value by RMS value. What is the maximum value? Vm. You can write it as Vm, and VRMS value 0.707 Vm. What is this value? What is this value? Just I want one of you to tell me what is the value of. You can cancel these and write 0.707. 0.707 divided by 0.637. So this is 1.11, and the other one is 1 divided by 0.1 divided by 0.707. So it is 1.41. So the firm factor of a sinusoidal waveform is 1.11, and peak factor of a sinusoidal waveform is 1.41. This you need to understand. So this is how you will find RMS, average value of a sinusoidal waveform, and RMS value of a sinusoidal waveform. This is RMS value of sinusoidal waveform. And we have got this as 0.707 Vm. Hope you are able to understand this. Let us consider, yeah, 1.109 and 1.415. You are very good. That's correct answer. Now let me tell you one more question. Let us take one question and try to solve it. I'll just take one question. The question is an alternating current. I'm taking this question from one of the textbooks. An alternating current takes 3.375 milliseconds to reach 15 amperes for first time before becoming zero. This is one. Then the question is find maximum value. Find maximum value if frequency is equal to 40 hertz. So first, whenever you are looking at a question, you need to write what is given to you and what you are need to find. Frequency is given as 40 hertz if you observe, and time taken is given as 3.375 milliseconds, and also you are given current I is equal to 15 amperes. You are also given time 15 amperes. Now let us find what we are asked to find. Find the maximum value, that is here the current, it is an alternating current. So what is the value of I maximum? So you can write this as what is I is equal to Im sine omega t, or Im sine omega is 2 pi f into t. So I is equal to Im into sine 2 pi ft. Now let us take this to the next slide and substitute these values. So this is, what is I is equal to Im sine 2 pi ft. What is I? I value is already given as 15 is equal to Im, you need to find sine 2 into pi. Pi is 180 into frequency is given as 40 and time is given as, what is time is given as 3.375. 3.375 milliseconds. It is 10 power minus 3. If you solve this, you will get Im as 20 amperes. So this is one of the simplest question that can be asked in the examination. Pictorial view is really superb, sir. Thank you, Rakesh. Thank you once again for thanking Unacademy. So now we will go for the other question. Let us say you have one more question like this. The question is, let us consider a question because we are lagging in time. So I want to take one more question, that is, let us take this question. I'm taking it from one of the reference textbooks. So the question is, find average value and RMS value of given waveform. The question can be this, or the question can also be something. I'll just tell you what is that. In the general university question papers, so this is the question given. This is given as theta and this as V, and this is given as Vm, and this value is given as pi, 0, 2 pi. So you need to understand one thing, that find the average and RMS value of the given waveform. Or he can also ask you question like this, find average and RMS value of full wave rectifier output. You can see this is the full wave rectifier output or half wave rectifier output. Even if this graph is not given, this waveform is not given, first you need to know Even if this waveform is not given, you need to first know what is the output of full wave and half wave rectifiers also. So this can also be the type of the question, or the other question type can be in the examinations. Find form factor and peak factor of given waveform. Even if you are asked about to find the form factor and peak factor, what is form factor? It is Vrms by V average. What is peak factor? It is V maximum by VRMS. That indicates even if you are asked about to find peak and crest factors, you need to find average and RMS values first. This is what you have to understand. So these are the different types of questions. Now let us try to find the solution. First I'll try to find, let us try to find what is the average value. We will also find firm and peak factors. What is average value? V average is equal to 1 by t integral 0 to t v of theta d theta. Right? So what is time period here? That is very important. You need to identify what is the time period. See, 0 to pi, it is repeating periodically. That means the period is 0 to pi, because the same waveform is repeating from pi to 2 pi even. So the periodicity here is pi. So t value is pi. So what is V average is equal to 1 by pi integral 0 to pi. It is a sinusoidal, right? So Vm sine theta d theta. So simply you can write 1 by pi Vm, if you take out 0 to pi sine theta d theta. So it is Vm by pi. We already know it is cos theta from 0 to pi, which is Vm by pi into 2 value this is. So this is 2 by pi Vm or 0.637 Vm. What is this? This is V average value. V average value is 0.637 Vm. Similarly, let us try to find what is VRMS value. What is VRMS is equal to root over 1 by pi integral 1 by t integral 0 to t V of theta whole square d theta. Now let us try to find this value. So Vrms is equal to root over 1 by t is pi integral 0 to pi Vm sine theta d theta. Yeah, V average is equal to 2 Vm by pi. Now Vrms is equal to square of this. So let us try to find what is 0 to pi Vm square sine square theta d theta. This is Vm square, if you can take out integral 0 to pi sine square theta d theta. It is Vm square of integral 0 to pi 1 minus cos 2 theta by 2 d theta. So see, because sine square theta can be written as 1 minus cos 2 theta by 2. So it is Vm square by 2, and you can take integral 0 to pi 1 is pi minus integral cos 2 theta is sine 2 theta by 2 from 0 to pi. Sine pi is 0. Sine multiples of 2 pi. So sine pi is 0. Sine 0 is also 0. So this is Vm square by 2 into pi. So you can substitute this value under root of 1 by pi. This integral value we have got it as Vm square by 2 into pi. So pi and pi would get cancelled. It is Vm by root 2 again. So what is Vrms is equal to Vm by root 2. Vm by root 2. It is 0.707 Vm. If you observe, the average as well as RMS value of a full wave rectifier is also same as the average and RMS values of a sinusoidal waveform. Hope this is clear for you. So this is the RMS value of a full wave rectifier output. Now let us consider one more waveform, and let me tell you the solution for that. Now let us consider a half wave rectifier output, or let us consider any other given question. Let me take this question as this. Find, the question says, I'll take this question. This is a bit different question which is also asked in your examination. Find average and RMS values of waveform shown in figure. This is the question, and the waveform is this. Let me take that waveform. The waveform is given like this. Let me consider this waveform. This is the waveform. Yes, this is the given waveform. Now the value here given is V, and this is Vm, and this is theta, this is 0, this value is T by 2, and this is T. Now if you try to find this, now if you are asked to find average and RMS values, let me start with finding, sorry, yeah, let me start with finding average. Before writing these average and RMS values, first you need to write what is the time period. What is time period? T is equal to if you observe this value T by 2 and also this till T, it is repeating. Now if you see, so the time period given is T. Time period given is T. So the time period is T itself. Now you need to split this, because from 0 to T by 2, that is from 0 less than theta less than T by 2, the value of V of theta is one value, and from T by 2 less than theta less than T, it is 0. So for this it is 0, and for this it is, directly you can write Vm. So for, and the other one is, here it is not given as T, it is given as theta, is it is not given as theta, it is given as T. So you need also to take here as 0 less than T less than T by 2. So it is 0 less than T by 2, it is Vm. From here to here it is Vm, and T by 2 less than T, in the between these two the value is 0. Now you need to calculate average value 1 by T integral 0 to T V of T dt. What is 1 by T? We will split this integral from 0 to T by 2 V of T dt plus integral T by 2 from T by 2 to T V of T dt. This is what you have to write. So V average is equal to 1 by T from 0 T by 2 to T, its value is 0. So if you substitute it here 0, this is 0. So 0 to T by 2 V of T value, or this is also V of T, sorry, V of T. So V of T value is Vm. So this is Vm dt. So V average is equal to 1 by T. You can write Vm, and integral dt is T. So you'll get T by 2. So it is Vm into T by T into 2. It is Vm by 2. Therefore, what is the average value? What is the average value? it is Vm by 2 or 0.5 Vm. Similarly, you can find what is the RMS value of given waveform. What is the RMS value of the given waveform? So first we write Vrms is equal to 1 by t root over integral 0 to t v of t whole square dt. So Vrms is equal to root over 1 by, what is time period here? 1 by t. T is the time period. So 1 by t integral 0 to t v of t. So we need to split that. 0 to t v of t dt plus t by 2 to t v of t dt. But this value is tending to 0 because v of t is 0 between t by 2 to t. Therefore, Vrms is equal to root over 1 by t integral 0 to t by 2 v of t dt. This you can write it as root over 1 by t integral 0 to t by 2. V of t value is Vm dt. So Vrms is equal to root over 1 by t. If you take Vm outside, it is integral 0 to t. We'll do that. Integral 0 to t by 2 Vm dt is equal to Vm, if you take out, it is integral 0 to t by 2 dt. That is Vm into t from 0 to t by 2. It is Vm into t by 2. So this is Vm into t by 2. You can cancel these two. This is, I'm sorry, this is square. So you'll get a square here. So this is a square. So Vm square, Vm square. So it is Vm square. Good evening, Shravan sir. Good evening, SVS Online Education. So it is Vm by root 2 again, or 0.707 Vm. You need to observe this square. Although I have forgotten it, you need to write this square. Vm square, Vm square. Root over Vm square is Vm by root 2. So this is the RMS value. So Vrms is equal to 0.707 Vm. So this is the RMS value. What is the average value? V average, what we got as V average? V average is equal to 0.5 Vm. Now let us say for the same question, find average and RMS value of the given waveform, and you are also find, let us say it is given, also find Kf and Kp, peak factor and form factor. So you need average value as well as RMS value. Now let us say Vrms is equal to 0.707 Vm is RMS value of that waveform. Average value was 0.5 Vm. Observe here, it is Vrms 0.707. So I have written 0.707. And if you take average, it is 0.5 Vm. So it is 0.5 Vm. Now let us find what is Kf. Firm factor is equal to Vrms by V average. What is RMS? 0.707 Vm by 0.5 Vm. I just want this value. And peak factor is equal to V maximum by Vrms is V maximum by, what is RMS value? 0.707 Vm. I want you guys to tell me these two values. What is 0.707 by 0.5? It is 1.414. 0.707 by 0.5. And next 1 divided by 0.707. It is also 1.414. 0.707 divided by 0.5. 1.414 and 1.414. So for this waveform, form factor, peak factor both are same. So in this session today, we have learned these things. One is what is a AC quantity, alternating quantity. Then I told you about what are the differences between DC and AC quantities, and I told you the basic definitions of waveform, time period definitions. Then we have discussed about RMS, average values, definition and formulae. Then we have seen what is perm factor and peak factor. Then I told you about some sinusoidal waveform, RMS average values and KF KP values. Then we have solved for full wave rectifier average and RMS values. So you have to remember that Vrms is equal to 1 by t integral 0 to t v of t whole square dt over the root, this is t, and V average is equal to 1 by t integral 0 to t v of t dt. And for also I have discussed what is symmetrical and asymmetrical waveform, and also what to find for a symmetrical waveform, and what how to find average value of a symmetrical and asymmetrical waveforms. This is what we have discussed today. Hope you have got. Good sir, nice explanation. Thank you Koteshwar. Ishwar 1.414, that's a correct answer Ishwar. Very good. And thank you all for this session. And as I always tell you, we have India's #1 study channels: Creatrix, Gate, Unacademy Gate, Unacademy Gate CE, Unacademy Gate Telugu, Unacademy SSC JE, Unacademy Computer Science, Unacademy Gate Questions, Electrical Junction, Unacademy Engineering Foundation, Unacademy Pathshala, and Unacademy Semester Exams. You can also join us on Telegram using https://t.me/creatrixgate. Please like, share, and you can use my code to get maximum discount of 10% using YSK10. And please do subscribe and click on this bell icon for the notification of my classes. Thank you all. Thank you once again for joining me today.